Welcome to section 4.1 on solving systems of linear equations by graphing. What I want you to start with is in your notes or wherever you're storing your notes and keeping track of things. I would like you to go ahead and take a moment, draw some coordinate axes here. Make sure you label your x-axis always with the x, your y-axis always with the y, and then see if you can graph those two equations, those two lines, and find the point of intersection. And then after you find the point of intersection, you're going to have an x-coordinate and a y-coordinate. Plug them both back into the equations and see if your solution actually does solve both equations. Because in graphing, finding the point of intersection is going to be synonymous with solving a system of equations. So eventually we're going to get to a place where we're going to say solve this system of linear equations. This particular way we're doing it, we're going to do it by graphing. So you're going to graph the two lines, but solving a system of linear equations is, what that means is you're finding out where the two lines intersect. So I'm going to pause and let there be some silence. You're going to hit pause on your device that you're playing this on, and you're going to take some time and do that. And then when you come back and hit play, I will walk through very, very quickly how to graph again and then how to find that solution. So go ahead and start or hit pause and start your graphing. Okay, so hit pause now. All right, welcome back. So here's what we're going to do. The quickest way that I always find to doing this is I'm going to plug in for x and y, a really simple and easy point. So if I put in 0 for x right here, 0 for x, I'm going to have negative 2y equals 6. And then to solve for y, I divide both sides by negative 2. And y equals negative 3. So I have a point 0 comma negative 3, which is 0 and then 1, 2, 3. This point right here is 0 comma negative 3. And then also I'm going to take a point and I'm going to put 0 in for y. And when I do that, this becomes 0. And I'll have x equals 6, which is just going to be simply and easy then 6, 0. So that point is 1, 2, 3, 4, 5, 6, comma 0. And I'm going to connect those 2 points as best as I can with a straight line and graph it there. I'm going to do the same thing on the other side for x and y. I'm going to put in a 0 for x, and I'll have 2y equals 2. So that means y equals 1 when I divide both sides by 0. Or sorry, when I divide both sides by 2. So my point is 0 comma 1. And remember, x is first, y is second. So x is 0, so I'm not going left or right. And I'm going to go up 1 to a point right here. Then I'm going to put in 0 for x. 0 for y. 0 for y. So 2 times 0 is 0, so I end up with x equals 2. So this is 2. So that point is going to be 2 comma 0, which means I'm going 2 in the x direction, 0 in the y direction, or 2 in the x direction, 0 in the y direction. And then if I can, I will very carefully and see if I can graph that line there. And it appears that these 2 points intersect at this point right here. And the coordinates of that point are 1, 2, 3, 4 over, down 1. So it appears that that point would be 4 comma negative 1. To check my answer, I'm going to put those numbers back in for the x and the y into each equation and see if it does hold true. So for this first equation, in place of the x, I'm going to put the x coordinate, which is 4, and then plus 2 times the y coordinate, and the y coordinate is negative 1, equals 2. So I'm going to have 4 plus negative 2 equals 2, 2 equals 2. Yes, it checks for this first equation. Then I'm going to do the same thing on the next equation. I have 4 for the x minus 2 times, and then the y was negative 1, equals 6. It's going to be 4, and then I have negative 2 times a negative 1 will be positive 2, equals 6. 6 equals 6. It checks for this equation as well. So I graph it, find out that point where they two intersect, and that's the solution by graphing. Here is the next set of lines I'd like you to graph. Find the solution, find out where they intersect, and then check both of your answers. I'll leave a little bit of silence here. You're going to hit pause, and then when you finished it, come back to see if you are right. Welcome back. The nice thing about these two equations is they're both in slope-intercept form, so it was pretty quick and easy to graph. So I started with my y-intercept at 2. Now notice I incremented mine off by going up by 2's, just because I didn't want to have, or I didn't leave myself enough space down below, because this one has a y-intercept of -6. So I went 2, 4, 6. So that's -6. 5 is the slope, so up 5. So 1, 2, 3, 4, 5 over, up, 1 over. Positive slope, the green line goes up. This one over here was 2 and -3 slope, so 1, 2, 3 over and 1 across, or 3 down and then 1 over. And then what I actually find is they both intersect at 1, -1. Again, plugging in those values, I will have -1 equals 5 times 1 minus 6. Is 5 minus 6 equal to -1? Yes, it is. That checks. For the other one, I put in the y value there, which is -1 equals -3 times the x, which was 1 plus 2. Is -3 plus 2 equal to -1? The answer is yes, so it checks there as well. Go ahead and graph these two. Hit pause, then graph them, and then come back. All right, so you'll notice again that this should be, in my case, is incremented by 2's, 2, 4, 6, because I have a -5 intercept, and my slope is 2, which is 1, 2, and over 1, 1, 2, and over 1. And if you remember anything, you also noticed right away looking at these two lines have the same slope, and same slope means parallel, and parallel means they will never intersect. So the other one intersects at 1, and it also goes up the exact same slope. So these lines are parallel. Parallel lines don't intersect, which means there is no solution. There is no solution since those lines will never intersect. Go ahead and do these, hit pause, and then come back. And what you found on this one then is if I graph this line over here first, and that's the purple line. I shouldn't have used red there, use purple. Purple line. All right, the purple line, and then I go to graph this line here in red, and I find that it is the exact same line right on top of the other line. They both have the same y-intercept, they both have the same slope. Where you plug in points, you end up the same values. They intersect at 3/2 right here. This point is 3/2, comma 0. But either way, what we find is all of the solutions, all of the points. So that means these, in terms of how I would write my solution, there are an infinite number of solutions. Or every point is a solution that's on this graph. So every point that's on this graph that's identical. So if I solve this, well, we'll do that later. And then here, I want you just to verify whether or not this point is a solution to this set of equations. You're going to take this for x, plug it in right here. Take this one for y and plug it in right there. And go ahead and hit pause, do your work. And then I'm just going to come back. I'm not going to show you any work, but I'll just tell you whether or not that this does check or if it doesn't check. So go ahead and hit pause and solve it now. Welcome back. And yes, indeed, it does work. That's supposed to be a star, or I can go like that and give you a big check. So then here we go. What's a significant drawback or challenge when trying to solve by graphing? Now, the ones that we did here were nice and easy. We could find the points exactly, plug them in and solve and see if they really work or not. What would you see as a possible challenge to graphing for any possible two lines that we give? And then the question will be, is there a better way? And the answer is yes. So there are challenges and drawbacks to doing graphing as my method for solving. And there are what we would consider to be, mathematically speaking, better ways to do it than by graphing. And we will be looking at a couple different ways. Some will be easier than others. There you go. Don't forget to do your check your understanding problems for 4.1. And if you did not already, you should have done last gathering that we had all of the odd problems from the exercise, the chapter review for chapter 3. All right, so the chapter 3 review exercises, all of the odd problems from that. And if you have the hardcover textbook of the latest edition, I believe it's page 275 is where those start with the chapter 3 review exercises. And they're, 1 through, what do we have? 55, doing the odd problems would have been done as well. That's all. We'll see you in class.